Hello there, I'm going to be talking about the binomial theorem. So the binomial theorem is a theorem to help with a plus b to any exponent. The formula is basically, okay, there's no paper, I'm not reading anything. The formula is basically a plus b parentheses to the n power, the sum of power n, k equals 0.
Is it equal here?
Huh? Yeah, k equals 0.
No, a plus b in the n power equal.
Equal, I'm sorry, dudes. Sorry. And then n choose k. N choose k.
I'm gonna explain what's choose k.
Yeah, I will explain it later, like after I'm writing down. Can you see, guys? Okay, n choose k times a to the n minus k power times b to the k power. That is basically it. And what you have to do to finish it is keep on doing this until it becomes n choose k, and 1k is the amount of n. So if n were 3, you have to do it to n choose 0, n choose 1, n choose 2, n choose 3.
And
So then you
the
stop.
sum from k, 1, 3, 1, 2, 3,
Yeah.
3, 3.
Yeah, exactly. And so what I said, I will explain what chooses are. I call it chooses. I have no idea what else to call it.
Is the mathematician call it chooses too?
No.
What they call them?
I don't know.
Why you call it chooses?
I don't know.
You heard it from somebody?
Yeah, I hear them go like n choose k, so I call them chooses anyway.
Oh, they call it
So
chooses.
these funky things are basically like n choose k basically means n factorial over k factorial times n minus k factorial. I hope that was big enough.
I hope you explain what's factorial. What's n factorial?
N factorial.
Can you write it down by the side?
Factorial, I don't know how to explain it, but it's a number multiplied by all the numbers below it.
Can you write down?
Except for 0 and all the negative numbers.
Can you do the n factorial? Is what?
I don't have a value for n.
Do it as n. So you're saying n times n minus 1 times
N minus 2 times
till
n minus 3 till 0.
till 0? So
Till 1.
Till 1. So till n minus n
Minus 1.
minus n minus 1. Maybe.
So if n were 3,
Till 1,
factorial would be 3 times
Explain by
2
example.
times 1, which is 6.
It's
So that's like a yeah.
Cascade multiplication.
Yeah.
Okay. Right.
And so
So
if
the
you want,
chooses is cool formula. N factorial divided by
yeah.
k factorial times n minus 1. N minus minus 1. What's this Chinese things here?
There's a factorial. That's a small combination of
So this is the what they call it.
binomial theorem. I'm gonna write it down.
So can you apply this, let's say, to a plus b squared? Let's say.
Maybe you can screenshot this. If you have an iPhone, you can screenshot it.
No, that's fine. But can you apply this, for example, with an example?
Okay. Just wait. I ran out of space with binomial theorem. Sorry. So if you want me to, I can apply it to something I memorized. And there's also another way to do this without any chooses, as I call it.
What way?
Really? Huh?
What way?
I'll tell you after I do the example.
Okay, because I have limited power in my video, so I got to do fast.
Oh, God. Okay, so what you do is a plus b to, let's say, the fourth power. What's going to be is first n choose 4. No, wait. 4 choose 0.
Equal here, but you keep forgetting dude.
I'm not a
You
dude.
call me dude when you forget that. I'm calling you back. So a plus b power 4 equal.
Equal. And then we're going to do a to the fourth power. No. A to the fourth power. And b is going to be 0, so it's just 1, or you don't have to write it. Plus. And then 4 choose 1.
So you're applying the formula.
Yeah. And then it's going to be a cubed and b to the first power, which is basically b. Plus, this might get annoying to you, but I can tell you a pattern. Because if you...
It's not annoying to me. I like it.
I can... There's a pattern. From the A, it's descending from 4 from the beginning all the way down to 0 or 1. From B, it's
not
going
sure about
up
0
from...
or 1. It has to be precise. Is it 0
Yeah,
or
to
1?
0.
Very good. Because math, it cannot be 0 or 1.
I have no idea. Okay. And the B...
You have to have...
I have an idea. Okay.
Very clear idea. What is it?
And for the B, it's going from B...
So one
From
ascending
the
one.
0,
How do you do that with the
0
hands?
power.
With the hands, the graph.
I would say like this.
Huh?
This is A, this is little b.
One is going down,
Yeah,
the
one
other
is
is going up at the same time. Okay.
Maybe like this. I hope this is A and this is like perhaps B. And one's going like this, and one's like going like this, and this is A and this is
When
B.
they cross, they will become having equal things.
Oh, it depends on what the exponent is. If the exponent's odd, they won't have the same exponents
Let's say
in
an
the
exponent
middle.
of 7. They cross where?
They will cross at 3 and 4 and 4 and 3. If A is 3 and B is 4, and 1 B is 4, and 1 A is 4 and B is 3.
You're sure about that?
I'm sure.
What's about if it's 3, not 7?
They will cross when A is 1 and B is 2, or B is 1 and A is 2.
What's about if it's even? The end.
Oh, then they will both cross at the same exponent. Like for the 4, they're going to cross at square.
2, 2. And then it's 8.
For 8, they're going to cross at 4.
4. Okay. That's extra information.
Okay, yeah, now you can continue the pattern on your paper if you want. Screenshot this, you can continue it, do whatever you want. Now I'm going to show you a way to do it with some other way. Say
So
maybe...
you did not finish it. But
No,
keep
you can
going.
continue it. Because
You
my
should
dad...
continue it.
No, you can continue it yourself. Because the camera, I think, is running out of time.
Okay,
So
can you explain, for example, this, how you do that?
yeah, and then you
Or maybe
continue
one
like,
this.
and then K equals 1, and then 2, and then 3, and then 4, and then until it's equal to N.
But can you do, like, for example, these 4 chooses 1 or whatever this is? Can you do it by applying these factorial things?
Nah, what do you mean? Yeah.
Yeah, do here. Let's say 4 chooses 4, 1.
Yeah, after this, it's 4 choose 1, so A is cubed, because 4 minus 1 is 3, and 3's got to be the exponent. You understand?
Yeah, but what's the number of this one? If you
Of
apply-
K?
Yeah. No, not the K. The whole thing. 4 chooses 0.
Oh, 4 choose 0. Yeah, you can apply.
Can you do it here?
You can apply it. See, look. 4 factorial.
Can you write it down by applying this example?
Yeah, it's going to be simple.
Can you do it here?
I can, okay.
Simple for you, but I'm still digesting things. On this video, maybe for people that they would love.
And then 0
to follow.
factorial. And then 4 factorial. Do you understand? Because 4 minus 0 is 4. And 0 is just 0. So 0 factorial is just 0. It's going to make it big.
0 factorial is 1, as far as I know.
0 factorial. Wait, what? I
Because
think it's 1.
Because if 0 factorial is 0, you cannot have a denominator 0. So that's
Okay, so it's 1. I
0
am
factorial
sorry.
correct your math. is 1.
Okay, it is 1, but 1, it's fine. Just cross it out if you want to.
So 4 factorial
And there's a
over-
remaining, so 4 over 4, 4 over 4. Ignore the factorials because they both cancel out.
Mhm.
4 can't. The 4's cancel out. The exclamation cancel out. Everything cancels out.
So equal 1.
You, especially you. So this equals 1.
What's
You
about
can
4
do-
factorial? What's about 4 chooses 2? Can you do me that?
Okay. Okay. So 4 factorial over 2 factorial times 2 factorial.
Mm-hmm.
Because 4 minus 2 equals 2.
Mhm.
Yeah. And so 2 factorial is 2. So you just multiply 2 by 2 equals 4. 4 factorial equals 24.
But why you have to go to that? Why you don't do 4 factorial is 4 times 3 times 2 factorial?
Okay, I'm doing it the way I want. I really do. I recommend to make sure it's right. Sometimes you
Okay.
make a mistake in the way he said it.
I see.
So sometimes you make a bad mistake.
Go ahead, Mr. Advisor. Okay,
But this
tell me
you
how
don't.
you do that.
So
4 factorial is what?
yeah, 4 factorial is 4 times 3 times 2.
So you convert it to normal number.
No.
So the number 4 times 3 times 2 times 1, 24.
Yeah, it's 24. And 24 over 4 equals 6. So 4 choose 2 equals 6.
Okay.
And now I'm just going to do another video and hopefully my dad will put on Facebook too.
Mm-hmm.
Bye.
What do you
See
mean? by-
video
was
2.
That? I
Yes.
thought that you're gonna do something else.
No, I'm going to do it in the next video.
What's that thing? What's the
Pascal's triangle.
No, do it here because I don't want to do 2 videos and it's gonna be long. So this is one
Okay.
way of doing things. You said, right?
The binomials. No,
Theorem.
you have to still continue the binomial theorem with
Okay, do the
just
Pascal.
another way of completing the binomial theorem
Okay, show
without
me.
any choices.
Without any choices. Okay, so the Pascal triangles get us away from the choices.
Yeah.
Those numbers of the
So
choices.
you see, I'm drawing a Pascal triangle
Okay.
right now.
Who invented that?
I think no. Pascal. Pascal.
Pascal.
Mr.
Sounds
Pascal.
French. Monsieur Pascal?
Yeah.
He was bored and then he invented that?
He invented it for many uses. Okay, so what I'm gonna do is this is related. So if you have a plus b to the 0th power, the only constant will be 1. Constant. Because
Consonant, he said?
this is
Const-
constant.
Constant.
I'm sorry.
Constant. I
Okay,
thought
so
you
this
were
is
talking
the
about
0 power.
continent.
This is the 0th power. This is the 1st power. This is the 2nd power. Square, are you following
I'm
me?
following you, yeah.
It's might be boring, but I have to complete this. So you just add these numbers. Shh. And then this is the 3rd power. Power. And this is finally the power we need. And all the constants, see, 4 choose 0 is 1, 4 choose 1 is 4, 4 choose 6. No, 4 choose 2 is 6. 4 choose 3 is 4. 4
So the
choose.
4 should be
Yeah.
here.
And 4
But how
choose
you come
4
up to
is
that
1.
4? Can you explain how you come up to those 1 and 4 and 6 and 4?
Oh, for the Pascal triangle? Yeah, you just add the numbers above it together like that. So you can just add 1 plus 1 equals 2.
So
and then
anybody
1.
can do that.
Yeah, anybody can do this and then goes till infinity,
what's
but I
about
don't
the-
think people will like it.
Yeah, for sure. Yeah. What's about the pattern about 1, 4, 6, 4, 1, 6?
Symmetrical.
Is it
Symmetrical,
wavy?
yeah.
Can you do it as a graph? Up and down, how it works? Like you did it here, for example. You said 1 ascendant, 1 descendant. How do you...
No,
how do
I
you
don't know
present that? 1, 4, 6, 4, 1. Is it the last one 6?
No.
Oh. Because I see 1, 4, 6, 4, 1. Oh, that's it?
Yeah.
Oh, so 1 like this.
Yeah.
1, 4,
So,
6, 4.
yeah, it's symmetrical.
So it's like this, curvy. Up,
Parabola.
1, 4, 6, 4, 1.
Yeah, it's just symmetrical. So anyway,
Can I do this if you don't mind?
I do mind.
So this is 1,
I do mind
Four.
indeed.
6, 4, 1. So, oh, maybe we're getting that.
It's not sure.
What do you call
And
it?
then
Parabola?
parabolic arc.
Oh.
And then so what you do is you grab the power you need. And those are basically all the consonants in order for you.
Consonant?
Constants in order for you.
Constants, okay. Okay, I get you.
This will refresh my mind.
So, A plus B,
Yeah.
more the
And
N
it's
is
all
higher.
the consonants.
Consonant?
Refresh my mind. Constants.
Constants.
Yeah, so they're all in order. So what I'd like to do is just grab the power, make them evenly spaced, like that. Good enough so we can write our A's and B's.
Go ahead, do the A's and B's.
And then so what you do is start from the number,
Higher.
the
K.
the
N.
the N.
The power.
Thank you. And then you go down, descending each time.
One descendant, the other one ascendant.
And this one is A to 0.
A's, okay.
And this one, then the B start from 0, B1, B2. And you have to add pluses like here.
Oh.
Yeah, you have to add pluses each time
Make sure
the
you know where to put the pluses though.
one number in A and B is done. Like
Plus.
1, plus, then I'm gonna add a plus,
So those are like
I'm
the
gonna plus
coefficients.
coefficient.
Coefficient.
Yes, they are.
Yeah,
And then in French it is.
coefficient. I read it.
Yeah.
Yeah.
He
Now, let
learned
me ask you
math
a question.
in
Now,
French.
if you do A minus B power 4, these become plus and minus somewhere, right? Or,
I think they're all minus. I have no idea. Maybe
oh.
the binomial theorem, the binomial expansion will might answer that question,
So
but
this
I have
one
no idea.
This theorem is only with the plus.
The positive, no.
Do you know?
I think it's if it's minus, I think it's all gonna be minus. But I'm gonna check
You have to check,
on
right?
Google.
So you're gonna do A plus B power n, which is this one, and you're gonna find out A minus B power n.
Yeah.
And that probably is the same logic.
Yes.
Just you have to understand where to put the pluses and the minuses. I don't think they're gonna be all minuses, to be honest with you. There will be, there will be minus and pluses, maybe alternation.
Maybe.
Yeah, we'll figure out.
I
Okay.
hope you didn't think this video is too long and boring.
It is 17 minutes so far, but it was fun. Thank you. It was inspiring.
Thank you, fellows.
Okay, thank you.